Question 5. The diagram below shows 4 coplanar horizontal forces of magnitude F, 12, 16 and 20 acting at a point P in the directions shown. So we're looking down from above on this diagram. Given the forces are in equilibrium, calculate the value of F and the size of angle alpha. Okay, so what we're doing here is we've got to work out the overall horizontal and vertical components of all of our forces. Let's just label in that's 10 degrees to the horizontal. They've just drawn it as 100 just to be a bit awkward. And I've just dotted in the vertical there. So what we're all going to do here is think about the horizontal forces to start with. Okay, and forces to the right will equal forces to the left. Okay, so the F force is pointing to the right, so's the 12. The 16 hasn't got anything to do with the horizontal, and that's being balanced by the 20 pulling that way. Okay, so we need to work out the component of the F force when we turn it to point directly horizontal. So that will be F cos alpha. We're going to have a 12 that doesn't need resolving, and that will be balanced by 20 twisted to the horizontal will be 20 cos 10. So we can actually work out F cos alpha as a number. 20 cos 10, take away 12. Comes out as 7.696. Then we'll do vertical. And for the vertical, we're going to say the forces up are going to be balanced by the forces down. So looking vertically, the F can be resolved to vertical. The 20 here is also has a little bit of component vertical. The 12 isn't going to come into the vertical, and they're being balanced by the 16 downwards. So F resolving to the vertical, we're going to stretch away from that angle alpha. It's going to be F sine alpha. Helping that will be 20 stretching up to there, so that will be 20 sine 10, and they're being balanced by the 16 that doesn't need an angle with it. So again, we can tidy that up, hop the 20 sine 10 across. If I do 16 take away 20 sine 10, that gives me 12.527. Now there's a nice little trick to work out F and alpha when you've got this situation. When you've got F sine alpha and F cos alpha, you can do division. So I need the decimal that goes with the F sine alpha to be divided by the decimal that went with the F cos alpha. The F cancels out, sine over cos turns into tan. So I need to do 12.527 divided by 7.696. That gives me 1.62, and I'll just press shift tan to give me an angle of 58.4 degrees. 1 decimal place is normally enough for angles. And then I can sub back for F. So I can sub into either equation. I'll go for 7.696 divided by cos of my answer. 7.696 over cos answer is 14.7 newtons. I know I rounded to 3 decimal places here, but that should be plenty to be accurate enough to 3 significant figures at this point.